Naming binary compounds. This time we're going to look at the binary molecular compounds that will be composed of two elements, and both of those elements will be nonmetals, so they will be found on the right-hand side of the periodic chart. They will be named differently because of the fact that two nonmetals can often get together in various combinations. And the best example for this is the two oxides of carbon. You want to make absolutely sure which one you're talking about. Carbon monoxide is deadly. I mean, you can kill yourself with carbon monoxide. Carbon dioxide, if that's the only thing there, of course you wouldn't have oxygen, but carbon dioxide is our waste product, and we bubbled into soda pop. So you want to make sure which oxide you're talking about. While the binary salts are very, very similar to each other, they are crystalline solids, there are a variety of properties for the binary molecular compounds. We have solids like silicon dioxide, which is sand, liquids like water, which is water, and gases like carbon dioxide. This is ammonia, and the formula actually represents a molecule. This is a covalent bond, and we are assuming that they are sharing electrons rather than having negative and positive ions that we have in the salts. So we will use a slightly different system of naming them. Again, two nonmetals sharing electrons. We're going to use prefixes to differentiate between them. For example, this subscript will end up becoming a prefix. So this compound will be carbon dioxide, telling you that there are two oxygens, CO2. So the name actually tells you the formula, so you will be able to go in either direction, formula to name or name to formula. The prefixes that will be used are from the Greek prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And from penta on, you can think of the shapes, a pentagon or a hexagon or an octagon, like a stop sign. So again, one of the important things will be that they will exist as molecules if they are soluble. A lot of them aren't, but if they're soluble, they exist as molecules and they exist as non-electrolytes. So, for example, when you have Gatorade, you have a bunch of electrolytes in Gatorade, which are the sodium ions, the chloride ions, and a few other ions. And then you might have the non-electrolytes, which would represent the glucose or the sucrose, if you buy the regular non-diet Gatorade. So, format to name the compounds. The first element, you will use a prefix only if there is more than one, and you will simply use the nonmetal name. For example, for CO, it would be carbon. There's no subscript on the carbon, so you simply say carbon. The second element, you will always use a prefix, and you will use the root with IDE. So for that second element, I will tell you that there's only one oxygen, and then I will use the root of the name with IDE. And because there are two O's right beside each other, I can eliminate one of those O's and just say carbon monoxide rather than carbon monoxide. And then CO2, I'll be writing carbon, no prefix on the first one, and then dioxide to tell you that there are two. And that's how simple and straightforward this is. So let me erase some of these since they're on top of the ones I have. We've just named the first two, but if you were to name the rest of them, N2O5 would be dinitrogen pentoxide. And again, I eliminated the A to make it sound better. This would be nitrogen monoxide. And then dinitrogen monoxide. And finally, carbon tetrachloride. And those are some examples of naming them. And I also have some examples how you can go the other way. Sulfur trioxide, S with 3 O's. Iodine heptafluoride, I with 7 F's. And then tetraphosphorus decoxide, I have 4 phosphorus and 10 O's. So it's pretty straightforward. There are some special names, and there are some groups of compounds that do not commonly use these systematic names. And what you should notice is that every single example I have here has an H in it, either in the beginning or at the end. NH3 is ammonia, H2O is water, H2S is hydrogen sulfide. Only one way they combine. You don't need to tell the ratio. And the rest of these are named the same way. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. pH3 is called phosphine. And ASH3 is similar to that, and it is called arsine. And CH4 is called methane, and this is just the start of a series that of carbon-hydrogen compounds, and they will end in ANE, but we will not actually be concerned with these, but you should certainly be familiar with these. This is a page that you can work on. I'll leave this open like this for a few minutes. You can either pause your tape here and do these problems. The next page I will have the answers to them. So really the best thing for you to do is to take a look at these and think, okay, what would these formulas be? And then go on and check them out. By the way, inert gases rarely form compounds, but a few of the larger ones do, and these would simply be named the way you named the rest of these binary molecular compounds. And we'll go on now and make sure that you don't, if you want to finish these, stop the tape before you go on. And this is what they should look like. And again, you can stop the tape and check them if you would like. By the way, I note that NO, the common name is nitric oxide, and N2O, the common name is nitrous oxide. This is laughing gas, but you can Google or look in Wikipedia for either of these, and you might be interested in their medical uses.